In this video, I'm going to test your understanding of isotopes, ions, and relative atomic mass with 10 rapid-fire questions. Pause the video when you need to, and think before I reveal the answer. Okay, first one. What is an isotope? This is one of those definitions that comes up again and again, and again. So we're not just memorizing it, we're understanding it. An isotope is atoms of the same element with the same number of protons but different number of neutrons. Here's what that actually means. Same number of protons means it's the same element because the number of protons defines the element. That never changes, but if the number of neutrons changes, the mass changes. So isotopes are identical chemically, but heavier or lighter versions of the same element. This definition, examiners absolutely love. Okay, think about this properly. Isotopes have different number of neutrons, so why don't they react differently? Why does chlorine-35 react in the same manner as chlorine-37? What actually controls chemical reactions? They have the same number of outer shell electrons. Chemical reactions are about electrons. Electrons are what get gained, lost, or shared. Neutrons just sit in the nucleus. They affect mass, but they don't affect chemical behavior. So if the isotopes have the same number of electrons, especially the same number of outer electrons, they react in exactly the same manner. This is a very common 2 to 3 mark explanation question, and the examiner is looking for those keywords. Electrons control reactions, neutrons do not. What is an ion? You've heard this word loads throughout GCSE Chemistry, but let's make sure it's sharp. An ion is not just an atom, it's something that has changed. An ion is a charged particle formed when an atom gains or loses electrons. Here's the logic. Protons are positive, electrons are negative. In a normal atom, they balance, but if electrons are lost, you lose negative charge, so the atom becomes positive. If electrons are gained, you add negative charge, so the atom becomes negative. Notice something important. Protons do not change, only the electrons move. That's why ions form during reactions. Question 4. How is a positive ion formed? Be careful here, this is where students panic in exams, but the logic is simple. By losing electrons. But let's understand why. Remember, electrons are negative, protons are positive. If an atom loses electrons, it loses a negative charge. Now there are more positive protons than negative electrons. That imbalance makes the atom positively charged. That is a positive ion. In chemistry, we call this a cation. And here's the exam tip. Losing electrons does not remove protons. The nucleus stays the same. Only the outer electrons change. Question 5. How is a negative ion formed? You already know the pattern now. Think opposite to the previous one. By gaining an electron. Electrons are negative. If an atom gains electrons, it gains negative charge. Now there are more negative electrons than positive protons. That imbalance makes the particle negatively charged. That is a negative ion. In chemistry, we call this an anion. Important reminder, protons do not change, the nucleus stays the same, only electrons are transferred during reactions. That's why an ion formation is about electrons, not protons. Question 6. Why do group 1 elements form +1 ions? This is not random, it's predictable, and examiners love predicting chemistry. They lose one outer electron shell, that's the pattern, but now let's go deeper. Group 1 elements all have one electron in their outer shell. That single electron is easy to lose. When they lose it, they reveal a full outer shell underneath. A full outer shell is more stable, and atoms always move towards stability, so they lose one electron and form a +1 ion. That's why sodium becomes Na+. That's why potassium becomes K+. It's not memorizing, it's pattern recognition. Question 7. Why do group 7 elements form -1 ions? Notice the pattern. Group number tells you something important. They gain 1 electron. Now let's understand why. Group 7 elements have 7 electrons in their outer shell. They are 1 electron away from a full shell, and atoms want full outer shells, because full outer shells are more stable. So instead of losing 7 electrons, they gain 1. That completes the outer shell, and that gives them a -1 charge. That's why chlorine becomes Cl-. That's why fluorine becomes F-. Again, not memorizing, understanding the pattern. Group 1 loses 1. Group 7 gains 1. Opposite behavior. Question 8. An atom has 12 protons and 10 electrons. What is its charge? The charge is +2. But don't just memorize it. Let's prove it. Protons are positive, electrons are negative. If an atom has 12 protons and 10 electrons, there are 2 more positives than negatives, so the overall charge is +2. Now lock in this formula. Charge equals protons minus electrons. 12 minus 10 equals 2. That gives +2. If there were more electrons than protons, the answer would be negative. Question 9. What is relative atomic mass? This is one of those definitions examiners love. The weighted average mass of an element's isotopes. That's the textbook answer. But what does that actually mean? Most elements don't exist as just one type of atom. They exist as mixtures of isotopes. Isotopes are atoms of the same element with different number of neutrons. That means they have different masses. So when you look at the periodic table, the number you see is not the mass of one single atom, it's the weighted average. Weighted means it takes into account how common each isotope is. If one isotope is very common, it affects the average a lot more. That's why relative atomic mass is often a decimal, like chlorine being about 35.5 because it's a mixture of chlorine 35 and chlorine 37. The periodic table shows the average. Question 10. Chlorine has 2 isotopes. Chlorine 35 makes up 75%, chlorine 37 makes up 25%. Calculate the relative atomic mass. This is weighted average. So what do we do here? The relative atomic mass is 35.5. Now let's see exactly how to get that. First, convert percentages to decimals. 75 becomes 0.75. 25 becomes 0.25. Now, multiply each mass by its abundance. 35 times 0.75 equals 26.25. 37 times 0.25 equals 9.25. Then we'll add them together to get 35.5. Multiply first, then add. That's the weighted average. And this exact calculation appears in GCSE exams. So you don't panic, you multiply, then you add. That's 10 rapid fire questions. If you're scoring 8 or more, you're exam ready. If not, rewatch and tighten those gaps. Next topic coming up. Subscribe if you're serious about improving your grade. Mr. Knows, knowledge beats luck.